frames of references, right? Or the reference frame. So what is basically the reference frame in physics? It is a kinematic condition of any body. Kinematic condition of any body. That means what कि अगर कोई body move करे, the any body is moving and it is moving with constant velocity, it is moving with accelerated motion. How we will find? We will find with the help of the reference frame. So in physics there are two types of reference frames. First reference frame is known as the inertial frame or the Newtonian frame, right? The second one is known as what? Non-inertial or non-Newtonian frames. Non-Newtonian frames, right? So when we are going to talk about the inertial frame, what does it means? In case of the inertial frame, what is going to happen? The velocity of the body is always constant, right? For example, we are moving in a bus and bus is moving at constant velocity. That means its acceleration is zero, right? Or either the body is at rest. Then also you can say the frame is inertial. Now what are non-inertial frames? In this case, what is going to happen? The velocity of the body will not be constant. Okay. That means in the same bus you are moving, but this time the bus is doing some acceleration. The acceleration will be non-zero here. So these are known as non-inertial frame. But the very important part is what? Whether you are solving the question with the help of inertial frame, whether you are solving the question with the help of non-inertial frame, the answer will be same in both the cases. दोनों cases में same answer आएगा. आप inertial frame से question को solve करें चाहे non-inertial से करें. Now why this topic is important? Because whatever you will solve in mechanics, all the questions that will be based on the concept of frames of reference. किसी भी question को solve करने से पहले चाहे we are doing the mechanics, we are doing electrostatics, we are doing the magnetostatics or any type of problem, we have to decide its reference frame, right? Now how to decide the reference frame? For that there are some basic principles of physics, so let us understand those principles also, right? So what are the basic principle behind this? Let us understand inertial frame and the non-inertial frame. So what are the basic principles? In case of the inertial frame, what is going to happen? That you can apply all Newton's law. Okay, all Newton's law are applicable here. Right. Now in this case, non-inertial frame, what you have studied in class when you are studying in normally the physics, people say that there no Newton's law is applicable. Now this is wrong to say. In this case also you can apply all Newton's law, but you have to give some special condition. Under some special condition only you can apply the Newton's law. This is very important. Okay. So what is a special condition? What equation we have to apply? See, in this case, inertial frame, the net force on any body will be equal to what? That will be equal to the real force only. That means you have to calculate all the real forces and apply the Newton's law and you can get the answer. Now, in case of the non-inertial frame, what is going to happen? Let us see that. In case of the non-inertial frame, what is going to happen? The net force will be equal to what? That will be equal to the real force. Plus, there will be one more force will be added with this. What is that force? That is known as the pseudo force. Right? Now, when you are saying what are the real forces are what? All kind of field forces. Right? जिसमें कोई field होती है. For example, what? Gravitational force. Right? Electric force. Right? Magnetic force and so on. Those will be the field forces. Right? Now, what is basically this pseudo force? It is a very detailed theory. Most of the time you are going to have the question जिसमें you will apply this equation only, that is the equation associated with the non-inertial frame, right? So firstly we have to understand what is basically the pseudo forces, and then we will be doing some kind of free body diagrams and we will solving some question, right? So every year 2 to 3 questions are asked in BITSAT exams on based on this topic. Okay, whether the question can be asked from mechanics, electrostatics, magnetostatics, and so on, right? So pseudo force समझना बहुत जरूरी है. So let us understand the pseudo force. So how will we understand the pseudo force? Let us do that. See, pseudo force. Somebody asks you what is the definition of pseudo force. Okay, for understanding it, just say the force which is not really pseudo. Okay, the fictitious force on the body. See, how will we identify the pseudo force? Simply for solving the question, what you have to do, you have to understand, just remember the formula. It is defined as mass of the body, okay, multiplied with acceleration of the frame. This is the formula of the pseudo force, right? And what is the direction of the pseudo force? This is also very important. Direction. कि pseudo force की direction क्या होगी? So the answer is what? The direction of pseudo force is always opposite to the acceleration of the frame. Okay, this is also very important. Now let us solve one problem. Okay, in fact we are going to solve the two different conditions in physics. See, this is a lift, right? Okay, and this lift, in this lift the one man is standing, right? And this lift is accelerating in the upward direction, the acceleration A. So what is the question that you have to draw the free body diagram of this body and find the net force which is acting on this man. So how to solve this question? Let us consider that we are also in the lift. So now we'll draw the free body diagram. So what is the first force? When the man is standing on the platform here, so what is going to happen? The normal reaction is acting on this body. Normal reaction is going to act in the upward direction. So this is N, right? The real force is acting on this body due to the gravity will be what? Downwards, that is M times of G. Okay. Because this lift is accelerating, so it is which frame? Yes, it is non-inertial frame, right? And in case of non-inertial frame, there will be one more force, which is the pseudo force. So where is the pseudo force now? The direction of pseudo force is what? It is opposite to the acceleration of the frame. See, acceleration is in upward direction, so pseudo force will be what? It is in the downward direction. So pseudo force will be acting in the downward direction. This is the pseudo force, right? So what is the pseudo force here? What is the pseudo force acting? The formula is what? Mass of the body. The mass of this man is suppose M times of acceleration of the frame. So what is pseudo force here? M times of A. Now simply you apply your vector physics. Okay, this is a vector here in the upward direction and two vectors on the downward direction. So the total force will be what? N will be equal to what? Mg plus Ma. Right? So M common, it is G plus A. Okay, and this is nothing but the apparent weight of the body. You will receive several kind of problem based on this topic, right? We'll solve bigger problems using the free body diagram. So this is just an example. Now let us just revert this example. Let us create one more condition. The same lift is there, right? Okay, on which again this man is standing, right? And this time the lift is accelerating in the downward direction. The acceleration of lift is A. Again, you have to find the net force acting on a man using the free body diagram. So firstly, when this man is standing on the platform, the normal reaction is going to act on this body in the upward direction here, that is N, right? The weight of the body is downward always, that is a real force, that is Mg. Now, because of the acceleration of the lift, it is non-inertial frame. So one more force is going to act, that is a pseudo force. Now, what is the direction of the pseudo force now? Pseudo force will be acting in the upward direction, right? यहाँ पे pseudo force जो है वो upward direction में act करेगा. So here is the direction of the pseudo force. Upwards. This is the pseudo force. Why in the upward direction? Because lift is accelerating in the downward direction, and we know that pseudo force is acting opposite to the acceleration of the frame. So what is the formula of the pseudo force? Mass of the body, that is M. This man's mass is M, and again the acceleration of the frame, that is A. So again you use the vector notation. So what this N plus Ma is going to add, because the two vectors are in the same direction. This will be equal to what? The weight of the body, that is M times of G. So what is the value of N? That is mg minus ma. So it is m common times of g minus a. That is the net force on the body. This is also known as the apparent weight. Right. So this is just an example how will you apply the equation, Newton's equation, using the basic concept of the reference frames. It is very, very important to understand. Right. Based on these, we will solve the questions. Okay, which is already being asked into the BITSAT exams. Right. These are the very important questions. All the questions which we are going to solve. And let us see one condition, let us see one type of question, okay, which is being already asked into the exams, okay, based on this concept. See what you have one lift here, right? Okay, and here is the wedge. This angle is theta, okay, and one block is placed here. The mass of this block is m. And this lift is again accelerating in the upward direction with the acceleration of a. So you had to find the acceleration of this block. Okay, what is the acceleration of this block? This is also very important question. So how will you find the acceleration of the block? Okay, firstly, what you have to do, you have to just draw the free body diagram here. So weight will be downward, that is m times of g. Normal reaction will be acting upwards here, that is n. This angle is theta. So this is mg sine theta, mg cos of theta. Okay, and here is the accelerating force, that is this one, that is mg times of sine of theta. So somebody will give the answer, the acceleration is g sine theta. Is it, this is right, g sine theta, writing here g sine theta, is it right? Well, the answer is what? This is not right. Okay, why this is not right? Because the net acceleration acting on this mass here, okay, will not be g. Okay, this g sine theta is a case when the wedge is not in the lift and when the block is not traveling in an accelerated motion. Okay, it is in the inertial frame. When the block is placed on the earth, then the acceleration of the block is acceleration of this wedge is what? 0. But the acceleration of this mass will be what at that time? If you do the component, this angle is theta. Again, you do that is mg downwards. Okay, and n upwards. And you do the components, then this comes out to be mg sine theta. So there you write this g sine theta, right? But in this case, this is not g sine theta. This is the question already asked. So we know by our concept that when the lift is accelerating upwards, okay, the acceleration, net acceleration on the system is what? On this particular block will not be g. It will be what? It will be certainly g plus a, right? So the answer of the acceleration, because you have to find the accelerating force acting on the mass. So what is the accelerating force acting on the mass is what? G plus A is the total acceleration, okay, on this mass system. Now the direction is what? Direction is favored by this component here. So that is favored by this sine component. So it is G plus A sin theta. So this is the answer of the question. Okay, so here this question has already been asked. Okay, and do the exams. I'm just giving the example. Then we will in the next class we will actually we will dictate the question and we'll solve the live questions here. Okay, that we will solve in the continuous classes. Just example I have given just to remove your misconception about this topic, because many students have the doubt when they have already studied in their school level. Okay, or might be you're going to some coaching you have studied, but that is wrong. Okay, this is what you have to follow. Okay, and this is very important. So we'll continue in the next lecture about all these things. Okay, thank you so much.